All right, this bad puppy. We're going to continue with where we left off, and that is apparently at organic compounds, drawing molecules and compounds, hydrocarbons, homologous series, and then combustion, which is a big thing that you need to know. Okay, starting at the start, which is organic compounds. Organic compounds are all molecules within chemistry that are C and H containing. So they contain C or H atoms, aka carbon or hydrogen. Okay, I need to get warmed up. Hydrogen. So if a molecule has two of these, they are part of the big box that we have of organic compounds. So these are organic compounds. This big box. We'll come back to this box. Okay, so any organic compounds are molecules that contain carbon and hydrogen. If it, for example, let's say we have I'm just going to draw it like this, CO2. Is this an organic compound? 9! Why? Because it doesn't have a hydrogen. It only has a carbon in there. What are organic compounds just in a more broader sense? These are, organic means life and compounds is just compounds in chemistry. So these are compounds and molecules that we find in living organisms. And so carbon and hydrogen are the base of life, the chemical base for life. So they have covalent bonds such as CO2. You would draw it as this with a double bond towards the O. These are covalent bonds. They're not ionic, they're not metallic. It is covalent bonds for organic compounds. And they have a C skeleton, so a carbon skeleton usually. That if there is a carbon within your molecule, it is usually found at the center of that compound because it is the point where everything branches off of. So we have carbon and hydrogen. It contains this. Often as well within organic compounds, what we see are, for example, oxygen, we see phosphorus, we see sulfur, we see nitrogen. I think that's the main ones. Yeah. So these are the main ones. CHOPSN. This is just extra information for you. Our bodies and almost every organism that lives on this planet is made predominantly from carbons, hydrogens, oxygens, phosphorus, sulfur, and nitrogen. So these are the main puppies in organic compounds. Main thing, they have to contain C and H, and they can contain others. So for example, let's take a look. If we have NaCl, is this an organic compound? Let's check it. Does it have a C? No. Does it have an H? No. So is it organic? No. Okay, easy. That is just how we do it. Next one, let's see, HCl. Sometimes confusing for people. Does it have an H? Yes, sir. Does it have a C? No, it has no carbon. Cl is a capital C, small n for chloride. This is not carbon. This is a different molecule. C and with a small little I, yeah? Or an L, sorry, Cl, chlorine. So no, this is not carbon. This is chlorine. Let's see another one. Let's say I do C2H6. We just check, does it have a C? Yes, sir. Does it have an H? Yes, sir. So this is a organic compound. Let's say C2O2H3. Is this an H4? Is this an organic compound? Let's see. Does it have a C? Yes. Does it have an H? Yes. So organic compound. Yep, that's just how you check through these. That is the organic compounds. Then drawing molecules and these compounds is quite a troublesome thing for many people. What we need to remember, first of all, with organic compounds, we have this thing of a C skeleton. So usually, if we have a molecule that contains carbon, you guessed it, that bad boy is in the middle. But let's recap what we learned in Unit 4. It's that H will start with the outlier. It only wants one bond. So if you have an H somewhere, it can only be connected with one thing. So for example, H connected to a C, or H connected to an O, or H connected to a Cl. It can only have let's see, the color's different now, one of these bonds. It can't have multiple. Why? Because it only wants one extra electron. It wants two in its outer shell. It has one, so it's going to search for its partner to give it that, and that is what that bond is, right? Because if you remember, one bond is equal to 2 electrons. Okay, so that's the why, and this is the rule you just have to know, that an H only wants one bond. Then if we look at the periodic table, we have something that looks a bit like this. Whoa, you get the idea. And then over here we have our group 18, over here 17, 16, 15, right? So if we look at these groups, group 17, they can only have one bond. This again has to do with the amount of electrons. They have 7 valence electrons, so they only want one extra. So if you're in group 17, such as, let's say, chlorine, it can only have one of these bonds. Maybe connected to an O, which is connected to something else, or a Cl connected to an H, or a Cl connected to a C. It can only have one bond. Same for fluorine, for example. Bromine, these are all group 17, can only have one bond. Group 16, they have 6 valence electrons, so they want 2 bonds connected to them. One of the examples here is oxygen. O2 looks like this. CO2 looks like this. Because O, it wants not 1, but 2 bonds attached to it, because it is in group 16. And then hopefully we're going to see a trend here. If it's from 17 to 16, now we have 15. And if it's from 1 bond to 2 bonds, I hope you see that this would be then 3 bonds. So for example, we have nitrogen, which is connected to 3 different hydrogens, for example, because it is in group 15. It has 5 valence electrons, so it wants 3 from its neighbors. Okay, then if we move down again, group 14, it will now increase to 4 bonds. And the main one that we're dealing with here in organic compounds is Mr. Carbon. So this guy wants 4 different connections, and there's a lot of different things that you have. Methane, for example, CH4, we have CO2, we have so much. It's a beauty to behold. Okay, so there's just a lot that happens with carbon, and that's also why we say that it is the skeleton of organic compounds. Why? Because it has 4 bonds, so it has so many places for the other things to attach themselves to. Whilst hydrogen, for example, it can only have that 1 bond. It can never be in the center because it can only attach to one thing, right? If I put it in the center, this is all wrong because I can only have that 1 bond for hydrogen. So this is also why carbon is that basis for life, because it has these 4 bonds that it wants to have with its partners around. So this is the rules that we have for drawing our bonds. And then I have 2 little tips that I like. It's 1, if there is a carbon, it is probably somewhere in the middle, right? Because it has these 4 bonds. It will be somewhere in the middle and stuff will be attached to it. Number 2 is, I think, a better tip, is that if you have an H, these will always be on the outside. They can never be on the inside because they can only have 1 bond. So all they can ever be is somewhere on the outside rather than on the inside. So same with CH4. Those H's are going to be on the outside because they can only have that 1 bond. Yeah. So usually we then ask to draw for different molecules, such as H2O. So let's do this one, H2O. What you have to think about before you start drawing is that these over here are our rules for drawing. And I have to make my drawing fit within these rules. That is my puzzle that I have to figure out. So something you can check is, okay, let's start at the start. How many H's do we have? We have 2 H's. And I have 1 oxygen. Okay, let's see my rules. H, it will always be on the outside. That's easy. And how many bonds does O want? Okay, it's in group 16. It wants 2 bonds. Okay, so an O wants 2 bonds attached to it. Cool. I have 2 H's, so I can just place these H's at those ends, and this is H2O. Easy enough. And I can always double check my answers. Yeah, I can check if my answer is correct, because how? I look at O. Okay, it's in group 16, so it wants 2 bonds. Does it have that? Yes, it does. 1, 2. My O is correct. Then I look at the H. How many bonds does the H want? 1. Is that correct for both H's? Yeah, they only have 1. So this drawing is correct. Next one, let's do NH3. How many N's do I have? I have 1 N. How many H's do I have? I have 3. Remember, this small digit is for the one before it. So I have 3 H's, 1 N. N is where in the periodic table? It is in group 15, so it wants 3 bonds. And we have 3 H's, so that's very perfect. So I'll put the N in the middle. I know the H's are always on the outside, so this drawing is also fairly simple. Done and dusted. And then I can again double check. N wants how many bonds? It is in group 15, so I want 3 bonds. Does it have that? 1, 2, 3. Correct. Next one, the H's want only 1 bond. This one has 1, this one has 1, this one has 1. It is all correct. I know I am right. A little bit more of a difficult one. H2CO. Skibidi. Okay. Let's start again. How many C's do I have? I have 1. How many O's do I have? I have 1. How many H's do I have? I have 2. Youpie. Then I look at my rules. Okay. C is going to be in the middle, H on the outside, and I know the amount of bonds that everyone wants. C is going to want 4 bonds. O is going to want 2 bonds. H is going to want just 1 little bond. And C is going to be placed in the middle. So I'll just draw C. And this guy can have 4 attachments, correct? Yes. So let's just add the O here. Let us add an H here and another H to this. Okay. And now I'm going to check. Am I correct? I have all of my atoms in here. Is it correct? Is this H happy? Yeah, it only has 1 bond. Is this H happy? Yeah, it only has 1 bond. Is my O happy? No. It only has 1 bond. And how many does it want? It's in group 16, so it wants 2 bonds. Okay, damn. So this guy needs 1 more, right? I need 1 more bond for this dude. Is my C happy? It has 1, 2, 3. Shoot. No. It's not enough. This guy wants 4, so this one also wants 1 extra. So what can I do? Single bonds are not the only bonds that exist. I just add a double bond here. And now everything is lined up and corrected. Yeah? So if you have a more difficult molecule, remember the rules that C is in the middle, H is on the outside. Simply draw everything with single bonds and check if you're correct. And if you're not correct, figure out which double bonds need to be reconfigured. So maybe one last one. CH3 OH. Okay, I have 1 C, I have 4 H's, and I have 1 O. So let's start. I know C is going to be in the middle because that's what it do. Then I have 4 H's and 1 O. Okay. I know the H's are always on the outside, so O has to be connected to my C, right? I cannot put an H and then connect an O to it. That won't work. Okay, let's do that. Then I can add the extra bonds here. Now I have 3 H's gone. I have 1 H left, so I can put that here attached to the O. And now I'm going to check, are all my H's happy? Yes, they all have 1 bond. Is my O happy? Yeah, it has 1, 2 bonds. Is my C happy? Yeah, it has 1, 2, 3, 4 bonds. Bing, bang, bish, bosh. All correct. And that is how you kind of check yourself for your drawings. So this we should already know from our unit in covalent bonds, but usually this is a struggle. And also, you will just get more used to it the more you draw. So if you struggle with drawing, just go online, search for some organic compounds, and just draw them, okay? That is my advice. That is the biggest part, and now we can quickly cover some hydrocarbons and some homologous series. So, back to this big square. We have organic compounds. This is this big group of molecules or compounds that contain carbon and hydrogen and can also have these different atoms in them. Hydrocarbons are a group within the group of organic compounds. So within this large group that contains C and H and can have other things, we have something, a smaller subgroup you could say, called the hydrocarbons. And as the name suggests, hydrocarbons are made of hydrogen and carbon. But this time, nothing else. So it is only hydrogen and carbon. That is what makes a hydrocarbon. Yeah? Organic compounds contain C and H and can also have an oxygen or a phosphorus or a sulfur, whilst a hydrocarbon can only exist with C's and H's. So for example, C2H6, or I draw this 3 C's over here with all H's attached. Yeah, that is going to be a hydrocarbon. The second I add anything else than a C or an H, that is not a hydrocarbon anymore. Then we are back into the organic compound territory. Yeah, so hydrocarbons are purely H and purely C. Okay, hydrocarbons come in 3 different homologous series. And what are homologous series? Let's go here. Homologous series are 3 little subdomains again in our little chunk of hydrocarbons. We have 3 little subdomains, 3 homologous series here. And what does a homologous series mean? It means a set of molecules that share similar properties. Bro, this typing is insane. Similar properties and reactions. So a homologous series is simply a set of molecules that share similar properties and react in a similar way. Yeah? And we have 3 of those that you need to know for our hydrocarbons. They are the alkanes, alkenes, and alkynes. I am so sorry for that. You see, the only difference here is from an A to an E to a Y. And what is the difference between alkanes, alkenes, and alkynes? An alkane only has single bonds. So only single bonds in a hydrocarbon. So for example, this would be an alkane. Because what? It only has single bonds over here. There's not a single double bond in sight, and that means that it is an alkane. Only single bonds. An alkene is at most, but at least, a double bond. Basically meaning any hydrocarbon that has a double bond in it. So here we see that there is a double bond, so this will be an alkene, sorry. Why? Simply because it has one double bond in it. That is all that it takes, okay? This is now an alkane. Alkene, alkyne. It's a bit difficult to wrap my little puny brain around at 712. Okay, so at least it has to have one of those double bonds, and that's also the most of a bond it can have. It cannot have a triple bond, because you guessed it, what happens then if it's a triple bond? It becomes an alkyne. It contains a triple bond. So for example, this molecule would be an alkyne, because why? It has that beautiful triple bond here. So quite an easy set of homologous series here. Alkane, alkene, alkyne. Simply look at your structure and see whether it has single bonds, double bonds, or triple bonds. And then you can just place them into the alkane, alkene, alkyne system. So for example, let me just draw you something here. This should be quite simple. is this an alkane, alkyne, or alkene? This has a double bond at most, so we have an alkane. Alkene, sorry, oh my lord. Oh my lord, an alkane. Alkene. Oh, I'm going crazy. Alkane, alkene, alkyne. Okay, so the alkane is over here because it has a double bond. If I draw another one over here, is this an alkane, alkene, or alkyne? It is an alkane because it only has single bonds. And if I draw something like this, it is going to be an alkene because it has a triple bond. Easy enough. So that is our 3 homologous series that you need to know for the hydrocarbon. Alkane, anyway. Alkene, jeepers. I just said jeepers in the Big 25. And alkyne. So simply said, single bond, double bond, triple bond. Yeah? So that is good to know. And remember the bigger picture that organic compounds form this big cluster in chemistry that contain molecules that contain carbon and hydrogen and can have some of these other ones. Hydrocarbons are a subsection in that big domain where they can only have H and C and no O's are allowed. And then within that box, we have 3 smaller boxes of alkane, alkene, alkyne. Yeah? And those are just simply, do I have single bonds, double bonds, or triple bonds? That is all that it is. So then we did hydrocarbons, we did homologous series. Combustion is the last thing that we need to cover. So for our hydrocarbons, if we remember, they can only have C and H, and that's it. And molecules that only have C's and H's are actually also our fossil fuels that we burn for energy. So these fossil fuels we dig out of the earth, we burn them, and it generates energy. And more specifically, we combust these fossil fuels. So what does combustion mean? So one fossil fuel is, for example, CH4, which is methane. So also what cows fart out. Methane. This is one of our fossil fuels. We also have C2H6, for example, which is ethane. Okay? So for all of these, I can just continue this as well. C3H6, C4H10, etc. What we can do is combust these things. Let me just put the names here. Propane and butane. So what does the combustion mean? Combustion simply means that we react one of our fossil fuels with oxygen and it turns it into carbon dioxide and water. This part, that is combustion, okay? When we combust a fossil fuel, we mean that we're adding oxygen into it. We add oxygen to our fossil fuel, it reacts with the oxygen and turns into carbon dioxide and water. That is combustion. So for example, let's say I want you to write down the formula for methane combustion. Okay, methane is CH4 and combustion means this. So I add oxygen and then I turn into CO2 and H2O. And then what I have to do is balance the equation, of course. So I have CH4 here. So 4 H's. Over this side I have 2 H's. So I put a 2 in front. And I have 4 H's here, 4 O's, 2 O's. There we go. So this is now a balanced reaction. Beautiful. Okay, so combustion simply means adding oxygen to a fossil fuel, which reacts with the fossil fuel, turning it into CO2 and H2O. Another thing it could be asked is give us the complete combustion of C3H8. Okay, let's do that. I just write C3H8. And what is combustion? it is plus O2 turning into CO2 plus H2O. And then I would have to balance this. So let's just do that. We have 3 C's on this side. We have 8 H's on this side. We have 2 O's. On the other side, we have 1 C. We have 2 H. And we have 3 O's. So let's change the C's first. We add a 3 in front of our CO2. Now I have 3 C's. I have 3 times 2, 6 oxygens here, plus 1 oxygen in the water. So that is 7 oxygens. Okay, H's are not equivalent. Here we have 8, here we have 2. So I put a 4 in front of this. Now I have 8 H's. Oh, look at this. Life hack. 8 H's, but also my O's increased to 10. 3 times 2, 6, plus 4 times 1 equals 4. 6 plus 4 is equal now to 10. 10 O's, so then I add a 5 in front of my oxygen, and then I also have 10 over here. That is how you would balance it. Okay, so that is organic compounds, drawing hydrocarbons, homologous series, and the combustion. So just to recap, organic compounds, big section within chemistry of compounds that contain hydrogen and carbon, and can also contain these different extra atoms, such as usually oxygen, phosphorus, sulfur, nitrogen, sometimes chlorine, sometimes iron even. It goes crazy. And within that big section of chemistry, we have hydrocarbons. Hydrocarbons, they are more niche because they can only have H and C. There is no O, P, S, or N allowed there. Only H and C's. And we have 3 homologous series of hydrocarbons that you need to know. Alkane, alkene, alkyne, distinguished by, do I have 1, 2, or 3 bonds? And what is a homologous series again? So all alkanes, they will react in a similar way and share similar properties. So all of these and alkanes share similar properties with each other. Alkenes and alkynes all share similar properties within their own series. That is what a homologous series is. For drawing molecules, remember these rules. H only wants 1 bond. Group 17 wants 1. Group 16 wants 2. Group 15 wants 3. Group 14 wants 4. And the biggest part here is carbon will be in the middle and H's are always on the outside. And don't forget that we have double bonds. We have triple bonds. Okay? So play around with it a bit. Connect everything first. H is on the outside. And if it doesn't match up, if the amount of bonds are not correct, you have to add in double bonds or kind of redraw it. This just takes practice. Google some organic compounds or hydrocarbons and start drawing. Yeah? Then our last part here, combustion, is simply this. Adding oxygen to one of our hydrocarbons and it being turned into CO2 and H2O. Okay? That is what combustion means. Adding oxygen being turned into. Yeah? This section right here is combustion. Coolio. That's it. Bye. Bye. Bye.